In this handout, or we're going to go ahead and finish the quadratic curve sketching handout here. So we left off on this particular problem, and in this particular problem our goal is to sketch the curve based on the values of a, b, and c. So to begin identifying these, the coefficient of the x squared term, the value multiplying the x squared, that's called the coefficient, and the coefficient here is 1. The b value is the number attached to the x term, which is 2, and the c value is the constant, which is -4. So remember, this guy is the initial value, this guy is the initial rate of change, and this guy is the change in the rate of change. So in other words, the change in y. Okay, well let's try to piece these together. So we know, twice this is the change in the rate of change. So in this situation, a is 1, means that our slope will be increasing by 2 as each input passes. So what I'm going to do is I'm going to pull this up in an Excel spreadsheet so that we can get started. Well, first of all, we know that the initial value is down here somewhere at -4. When x is 0, y is -4. So I have that here in my table. Now my initial rate of change, we're saying, is 2. So that means that when x changes to 1, my output, well, it's going to be -4 plus 2, and -4 plus 2 is going to give me an output of -2. So that means that over here we're going to have a positive rate of change, which is going to take me back here. So we'll say that's 1 unit of input, 2, 3, 4. That's the only thing I'm going to label is the inputs themselves. The outputs, I just want to make sure I'm drawing consistent lines with consistent slopes. So there's over 1, up 2. All right. So I have a positive rate of change, but what's going to be happening to my rate of change? Well, we're saying that twice the value of a, which is 2 times 1, which is 2, means my slope, my change in y, is going to grow by 2. So now my change in y is going to be 4. 2 plus 2 gives me 4. So that means my slope is now 4. So when x changes from 1 to 2, my output's going to change from -2 plus 4 to +2. So that means that my slope is actually bigger. That's the important part. It's no longer over 1 up 2, it's over 1 up 4. So the slope is a little bit steeper. It looks like that, and then it gets steeper. Well, you can probably gauge the pattern that the slope is always going to grow by 2. So the slope is going to be 6, 8, 10, 12, 14, 16, and so on. So all we really care about is the fact that the slope gets bigger. So if this is the change in output for the previous input, then the next change will be a little bit bigger. And hence we kind of get a curve that looks like this. In the next example, we'll do a couple here and give you a chance to think about some of the others. So let's look at this one. -x squared plus 2x plus 4. So what does this mean? Oh, and by the way, when you actually do this method of calculating your change in output and then calculating your y's, you'll notice that the actual outputs are -4, -1, +4. And you might be wondering, well, if this is correct, then why are we getting different outputs? In calculus, you'll actually learn that the rate of change is not really constant between input units. So we're assuming that the output is going to change by 2 exactly, but it actually doesn't. So don't worry too much about that. The goal is just to get a good sketch. If we want to be exact in the outputs, we'd actually create a table where it would be x squared plus 2x plus, minus 4. And we could calculate all the outputs that way. Okay, so in this one, we have a is equal to, in this case, -1. B is equal to 2, so I have a positive initial rate of change, and C is equal to 4. I have a positive initial value. Well, this means that my slope is going to be changing by 2 times A, which is -2. So my slope is actually going to be dropping by 2. It's going to be getting more and more, it's going to be getting smaller, in other words. So initially, I will start up here at 4. My initial rate of change is +2. So when I increase my input by 1, my output's going to go up by 2. But now we're saying that the slope gets 2 units smaller. So if I have over 1 up 2, and I decrease that slope by 2 units, I have a slope of 0.